Optimizing a function is the process of identifying all extrema for a function. Extrema is just a single word that lets us more concisely say maximums and minimums. So rather than keep saying we want to find all maximums and minimums of a function, we can say we want to identify all extrema, and this whole process is referred to as optimizing a function or function optimization. We'll start off by looking at how we do this from a graph, connect it to some information about the first derivative so that we can see how we could extract this information or build towards extracting this information from the function itself. What we're going to do is construct a sign chart for the first derivative of the function f of x that we have graphed here. Given what we already know about derivatives, we know that the derivative function tells us about the rate of change of a function at any point. So if we see our original function decreasing, that means that the derivative function would take on negative values for any of those points. That happens again on this interval between 2 and 4. So on any of these intervals, the numbers that we plug in between should yield a negative value for the derivative. And then as we read from left to right, if we see that our function is increasing, we should get positive values for the derivative function, the first derivative function. And we have two different intervals where that would occur in this scenario. And what we have at those points in between, somewhere our function, if it's continuous, has to change between increasing and decreasing, or decreasing and increasing. So in this case, at x equals -1, our derivative function would have a value of 0. To change from negative to positive, we have to pass through 0. At x equals 2, our derivative function would have a value of 0. And at x equals 4, our derivative function, first derivative function, would have a value of 0. And we can tell just from looking at the graph what we have mapped out here. We have a local minimum, we have a local maximum, and we have a local minimum again. Because in each case, that point or that function value takes on either the highest, the largest, or the smallest function value of any of the points around it. So anywhere on a graph that we see the bottom of a valley, we would have a local minimum. Anywhere we see a peak or the top of a hill, we would have a local maximum. And what's happening with our first derivative function is that the sign of that first derivative is changing at those points. Either it's changing from negative to positive, or it's changing from positive to negative. Wherever we see the sign of the first derivative change, that's going to correspond to either a local maximum or a local minimum. And then we just have to think about the behavior. Is it changing from decreasing to increasing or increasing to decreasing?